Okay, so here we go. I'm trying this out for the first time, see if it works. So what we're going to take a look at here is how we go about calculating the slope of a function at a point. As you know, if you take a linear function, for instance, the slope of a linear function is always the same regardless of where you're at. But if you have a curve, the slope changes. So here is how we calculate the slope of a function at a point. Bear with me while I get this to work just right here. Okay, the slope of f of x at x equals a is equivalent to the slope of its tangent line at x equals a. So what I've done here is I've drawn the graph of a function. Might be a little bit of a problem here. The cat is coming. Anyway, so I've Conan, get out of here. Go. So I've drawn a quadratic function here. And you can see here at the point where x is equal to a, I've drawn what's called a tangent line. A tangent line is a line that just touches the graph at that point. So the slope of a function at any point is equivalent to the slope of its tangent line at that point. So if we knew what the slope of this tangent line was, that would be the slope of the curve at that point. Okay, so how do we go about calculating the slope of that tangent line? Slide this on up. Hey, the slope of the tangent line to a function f of x at x equals a is given by the following limit. The limit is h goes to 0 of f of a plus h minus f of a all divided by h. Now, if this fraction looks familiar, it probably should, because you probably saw this in pre-calculus 1. It was called a difference quotient. And as I always tell my pre-calculus students, they're going to need to know how to evaluate these because it's necessary in calculus for finding the slope of a curve. And I also say here, provided this limit exists, because as we'll see in the future, there are some situations where this limit may not exist. Okay? So this is a formula for finding the slope of a tangent line to a function at any point. And as we set up here, the slope of a function at any point is equivalent to the slope of its tangent line at that point. Okay? So let's look at a sample problem. Alrighty, here we go. Bear with me, I'm doing the best I can here. So the first thing we're going to look at is find the slope of f of x equals 3x plus 2 at x equals 3. Now, you should already know the answer to this problem. Note that this is a linear function, isn't it? Highest degree is 1. So the slope of this linear function is 3. So regardless of what point we're at, the slope of this function is going to be 3. So we already know the answer, but let's use our formula for the slope of a tangent line to figure it out. Okay, so here I have the definition for the slope of a tangent line. In this case, a is 3 because we're looking for the slope at this specific point, x equals 3. So the slope of the tangent line is going to be the limit as h goes to 0 of f of 3 plus h minus f of 3 all divided by h. So here's my f of 3 plus h, which is 3 times 3 plus h plus 2. Remember from pre-calc, if you want to evaluate f of 3 plus h, you simply take your function up here and replace the x with 3 plus h. So this part right here is f of 3 plus h, and then I subtract from that f of 3. So here I have minus f of 3, all divided by h. And then when we do the algebra on the top, you know, distributed property, and this here comes out to be 11, so it's minus 11. Next line down looks like this. Limit as h goes to 0 of this fraction. And notice that we have 9 plus 2 here on the top, which is 11. Take away 11, of course, it's just 3h. And as we know from algebra, we can cancel the h's, and we end up with the limit as h goes to 0 of just 3. But as we learned with our limit laws, the limit of a constant is just going to be the constant. So the slope of this function at the point where x is equal to 3 is simply going to be 3. But as I said before, we already knew that. This is a linear function, and its slope is going to be 3, no matter what x value you pick. So it doesn't matter what number you put here for x. When you go through all this work right here, it's always going to come out to be just the slope of the linear function. So what about a function that's not linear? Let's try this problem. So let's find the slope of f of x equals x squared at x equals 2. On this one, I've actually drawn a picture of the graph of x squared, and I've also drawn a picture of the tangent line at x equals 2. As we said before, the slope of a function at any point is equivalent to the slope of its tangent line at that point. So let's go ahead and calculate the slope. So I have the formula for the slope of a tangent line. In this case, a is 2, because we're trying to find the slope when x is 2. And so this is now this right here is f of 2 plus h. If f of x is x squared, then f of 2 plus h is going to be 2 plus h squared. And then of course we subtract f of 2, and f of 2 would be 4. So here's my f of 2 plus h minus f of 2. When we do the algebra here on the top, distributive property FOIL method on that part, we get the limit as h goes to 0 of 4 plus 4h plus h squared minus 4 all over h. And of course the 4's cancel out real nice. Leads me to this limit. Limit as h goes to 0 of 4h plus h squared all over h. And as we probably know already, you can factor the h out of the top, in which case the h on top that you factored out cancels out real nicely with the h on the bottom. And we simply have the limit as h goes to 0 of 4 plus h, which we can evaluate with a direct substitution and get an answer of 4. So the slope of this function right at that point right there is exactly 4. So if we went a little bit beyond 2, the slope would be a little bit more than 4 because the tangent line would be steeper. If we went a little bit below 2, the slope would be a little less than 4 because the line's not quite as steep. Now I've got one more example here to do before I try to upload this. We're going to find the slope of f of x equals 1 over x at x equals 2. Once again, I've drawn a picture of the graph. Here we have the function 1 over x. That should also be a familiar function from pre-calc 1. And right at the point where x is equal to 2, I've drawn a picture of the tangent line at that point. Always remember that the slope of a curve at any point is equivalent to the slope of the tangent line at that point. So if we want to find the slope of the function here, we need to find the slope of its tangent line at x equals 2. So what are we going to use? That's right, the formula for finding the slope of a tangent line. Once again, in this case, a is 2, because we're looking for the slope at x equals 2. Okay, Conan, get out of here. Okay, so f of 2 plus h in this case, well, if f of x is 1 over x, f of 2 plus h is going to be 1 over 2 plus h. And then we subtract f of 2, which of course is going to be 1/2. And then, now the algebra gets a little tricky here. Got to remember how to do complex fractions. So I note here that the least common denominator of these two fractions is 2 times 2 plus h. So I multiply top and bottom, by 2 times 2 plus h. And then when I do the distributive property on the top, you should end up with 2 minus quantity 2 plus h. Multiplying the first fraction by the LCD, the 2 plus h's cancel and give you just 2. Minus, multiplying the second fraction by the LCD, the 2's cancel, and you just get minus 2 plus h. And doing the arithmetic and algebra on the top, you'll end up with 2 minus 2 plus h, which of course is 2 minus h. Remember, the minus sign distributes. And 2 minus 2, of course, is 0. So we now have limit as h goes to 0 of this fraction. And the h's cancel out real nice. Leaves me with the limit as h goes to 0 of negative 1 over 2 times 2 plus h, which is a limit that can be evaluated real quickly with a direct substitution, and we get an answer of negative 1/4. Now, why does that answer of negative 1/4 make sense for this problem? If you go back and look at the original graph here and the tangent line, would you agree that this tangent line has to have negative slope? Because it's going from upper left to lower right, it's going down, has to have a negative slope. Okay? So it makes sense that our slope here came out to be negative 1/4. Okay. So that's all for now. I'm going to try to upload this now to the internet, and then I will also include a homework assignment for us to try. So that's it for now. We'll see you on Wednesday.